Hello, today I'm going to go over the Exoplanet Lecture. So exoplanets are planets that are not in our solar system. So we're used to Mars, Venus, Jupiter, Saturn. Exoplanets are around other stars. So exoplanets are planets that we have discovered outside of our solar system. The first was discovered in 1995. So we always suspected that other stars had planets, but until you have proof or evidence of that, you don't know for sure. Okay, so how did we first find an exoplanet? It was not by using a telescope to see the planet. We had to detect evidence of it. So what we see here is looking at a star that wobbles in a certain way because there's a planet going around it. So the gravity of the planet affects the motion of the star. The first exoplanets were discovered using the Doppler effect. If an exoplanet is around a star, the star will wobble slightly from the gravity of the planet. So this was the first way of detecting exoplanets, but the planet had to be pretty close to the star for us to be able to do this. As we continued to investigate exoplanets, we found other methods. This was a very popular one. This is called a planetary transit, where you see the star here and the planet is going past the star in its orbit and then around here. And we can record the brightness coming from that star very accurately. So planetary transits are another method of finding exoplanets. When the planet passes in front of the star, it blocks some of the light, and we can detect this decrease. So even though it only blocks a little bit, we can still detect that. Later on, as we got more space telescopes like Hubble and the James Webb, we're able to image evidence of planets. Again, not the planet itself, but evidence. And that's the series of images here. Even with our powerful telescopes, we have a very hard time imaging exoplanets. However, we can image evidence of planet formation as seen in the proto-solar system above. So what we see is a star or a star forming, and then there's a little dark space around each of these. That's because planets have formed, and instead of all this dust and gas material, the planet has coalesced all that stuff. So now there's a planet in this empty space going around the star. These are early solar systems. Okay. So this is another image that we've taken using telescopes. This is another image of an early stage solar system. So again, this is a solar system that is starting to form. There's still lots of debris, gas and dust in the solar system. The dark rings in the disk are likely areas of planet formation. So anytime we see this area where it's a dark ring, where there's no material, that means a planet is forming there as it sucks up with gravity that material, that dust and gas. They are dark rings because most of the material has coalesced into planets. All right, and then the bottom one is a graph showing you, after collecting lots of data now, how common it is for certain size planets. So these are like the inner planets, like the size of Earth or Venus. Looks like they're very common. Larger planets like Jupiter and Saturn are less common. After collecting a large amount of data, we have concluded that most of the other planets in star systems are closer to the size of Earth rather than the size of Jupiter. Okay, so this is an introduction to exoplanets. I hope that helps.